All right, graphing tangent. So we've got f of theta equals tangent of theta, and think of this as f of x. The variable that we're plugging in though is the angle measure. And so a few things you may notice already immediately just looking at the graph, that we are changing our x-axis or axis. It's not just 1, 2, 3, 4. We're going to be changing this to our kind of key points on our unit circle. So here we've got 1/2 of pi, 3/2 pi, 2 pi, so on, so on. Going to the left, it's negative pi over 2, negative half of pi, negative pi, negative 3/2 pi, and negative 2 pi. And going up or down, and you notice that we've got just the value of 1 plugged in up above and below. And let's, for graphing tangent, let's start by just looking at, well, what's sine of x look like? And so let's go ahead and, on our calculators, make sure you are in radians as you're graphing those. And so let's graph. And just that nice, smooth, easy sine wave. And so there it goes, and its maximum value is 1. So it's got, and its minimum value is 1. So 1 minus negative 1 gives you 2, and 2 divided by 2 gives you your amplitude. So your amplitude here is 1. Your domain for that, you can plug in any theta theta values you want to, so or any x values. So your domain here is all real numbers. Your range goes from 1 to -1 or -1. The x or theta is between -1. Sorry, your y value, your output is between -1 and 1. Your period is going to be from one crest to another crest, or any point to its next relative point, until we end up with a period of 2 pi, the one time around that unit circle. And we've talked about that a little bit already, but just wanted to kind of, as we head into tangent, talk about something because it's going to perhaps catch you a little bit off guard. So there's sine, and now let's graph cosine. Again, this smooth, easy graph, and it has actually the same period, amplitude, domain, and range as sine. And now here's tangent. So maybe you're thinking, hey, tangent's going to look similar to those two. Let's graph it up. And we get this bizarre looking graph that looks nothing like sine or cosine. And in fact, your calculator can't even graph it perfectly. It doesn't get higher or get lower down at points. This is just a fault in the calculator that the calculator can't get exact enough. And so though this basic shape will help us realize there are some shortcomings in it. So let's graph it by hand. So tangent of theta. So remember, tangent is going to be equal to sine over cosine. And so let's talk about, or sine of theta over cosine of theta. Let's talk about some points that sine is 0, because then who cares what cosine is? We'll have 0 divided by some value. And we should make sure that that value is also not 0. But sine and cosine are never 0 at the same place. So we're okay in that regard. So where is sine equal to 0? Well, sine is going to be equal to 0 when we're at 0 pi. So we better get 0 right here, and we'll graph it in. Let's go with red. At 0 pi, sine is 0, and so sine divided by or 0 divided by 1 gives us 0. And where else is sine equal to 0? Well, sine is also equal to 0 at pi, at 2 pi. And at every pi, it's going to be back to 0. Same thing going clockwise, going negative. So at negative pi and at negative 2 pi. Again, we're hitting 0. All right, well that's good. What about when cosine is 0? So what do we have there where cosine is 0? We'll have sine will either be 1 or negative 1 in those locations. And we're going to end up with undefined. Undefined. And our undefined on our graph gives us an asymptote. Remember, asymptotes are asymptote. Asymptote is going to be, we'll have one in just a second here, where cosine is going to be 0. So where's cosine 0? Well, it's at 1/2 pi, or pi over 2. Pi over 2 is going to have an asymptote at 3/2 pi. 3/2 pi will have an asymptote. There we are. And keep on going around. We'd have one. Oops. Once we're at 1/2 pi, then every pi after that will have another asymptote, and every pi the other way. So if we start at 0 and went negative 1/2 pi, we have an asymptote, negative 3/2 pi, an asymptote, and so on and so forth. Now, from there, we got to graph this a little bit more, and so we can see some zeros, we can see the asymptotes, and from there, our sketch is going to look a little bit like this here. Do my best to sketch it. Probably a little flatter coming off here. Because as the values get for sine get cosine get closer and closer and closer to 0, as they get closer and closer and closer to 0, it's going to divide sine into smaller but more and more and more pieces, and so they get either infinitely bigger or infinitely smaller, depending on whether cosine is going to be negative or positive, or sine is going to be negative or positive, and we end up with this graph looking something like that. And that's not the most beautiful graph in the world, but hopefully you get an idea, and you can see how the calculator then might be, oops, went away, might give you something looking like that. So again, it's not growing here, not getting higher. It's just a shortcoming in the calculator. This is going to be the same exact shape repeated over and over and over. All right, let's go and answer some of these questions now. So how often is this graph repeated? And it's probably easiest to go from 0 to 0 here, or even from an asymptote to another asymptote. And the period here is going to be pi. If this was all in degrees, then this would be 180 degrees. Every 180 degrees, this graph is repeated. So it's repeated more frequently than sine or cosine. Its amplitude, whether its maximum, well, its maximum's, I guess, positive infinity, and its minimum is negative infinity. And we actually don't have a amplitude specifically. It's none. It doesn't apply. It's uncalculable. But we'll stick with that. It doesn't have an amplitude. It's heading to infinity, and then it heads at points. It has just an asymptote. Its domain. What x values can we plug in? Well, we can't plug in any x or theta values. The theta can't be. Oops. Theta cannot equal 1/2 pi. And then adding, so it's first one that can't be, and then pi times n, or actually put right, n times pi. N times pi, where n is an integer, where n is an integer, either positive or negative. And because that's the n being the number, or sorry, an integer, and pi being the period. So from this point of pi over 2, our asymptote right here, if we add pi, we get back to more and more domain values that that theta can't be. Or if this was in degrees, this would be 90 degrees. 90 degrees that it cannot be equal to 90 degrees plus n times 180 degrees, because we'd get back to another asymptote at every point there along the way. Its range, is there any values of y that we can't get out? No, and this one's going to be all real numbers. Its range is all real numbers. All right, knowing that, go ahead and actually we'll just do this in the next video because we've gotten kind of long here as it is. But try to figure out if you can find the graph for cotangent of theta. And maybe kind of rush through that part, but maybe think through why did this go negative here? Why didn't this start as a positive and head down towards the negative? We'll talk about that a little bit in the beginning of the next video, but see if you can figure out what the graph of cotangent of theta might look like. All right, hope that helped.